So now let's derive an expression for electric field at any equatorial point due to an electric dipole. So for that, let's make a diagram first. Suppose there are two charges such as these, and they are separated by a distance 2L, as we already know the distance between the two charges. So this is minus Q, this is plus Q, and say let's name them as A and B, charge A and charge B. Now let's make a equatorial line, which is nothing but the perpendicular bisector of the line joining the 2 points, meaning this is perpendicular and this joins at their midpoint. Now here, suppose we need to find out electric field at this point, any general point P. So somewhere here. So let's name this as P. So now let's join the line and complete the diagram. Say this point is connected to this charge as this. In the same way, we'll join A to point P, something like this. Okay. Now since A is negatively charged, so electric field would be towards A because of this charge at this point, and since B is positively charged, so electric field would be away from it, so it would be say somewhat like this. So say this is electric field at P due to B, and this is electric field at P due to A. Now suppose this angle is theta, and since this is the midpoint, so the distance between them is L, and also distance from say P to O, this distance is R. Now since electric field is represented along these two lines and this is theta, then this would also be theta, and even this would also be theta. This would be theta as these two lines are parallel, so interior angles, and this is also theta, so these two angles are also same as corresponding angles. Now since electric field is a vector quantity, so it would have components. So EPB, electric field at P due to B, would have two components. One would be with this dotted line, blue line, which is EPB sin theta, and the other one would be along this line, which is EPB cos theta. Same way, electric field at P due to A would have two components, one along this line, which is EPA sin theta, and the other along this line, which is EPA cos theta. Okay, now since we can see the components here, like sine and sine components get cancelled out, since electric field at P due to B can be given as, suppose this PB is some x, and same way PA would also be x, as these two angles are similar, so the side would also be same. So EPB as magnitude is same as EPA, which is given by K dash Q upon x square. And by the way, K dash over here is given by 1 upon 4 pi epsilon. Okay, so we know expression for EPB and EPA are this. Now if we need to find out electric field at any equatorial point, it would be EPB cos theta plus EPA cos theta, but since EPB is same as EPA, so this can be written as 2 times of EPB cos theta or 2 times of EPA cos theta. Now EPB, as we already know the expression, so it will be 2 times of K dash Q upon x square into cos theta. So this is E equatorial. Now if we see the diagram, this is R this is x, and this is L, and this is 90 degrees. So using Pythagoras theorem, what you can write is x is equal to root of r square plus L square. Thus we can use this x in equation, say this is equation 2, in equation 2 here. So let's use it and write the next step. So 2k dash q upon, and since this is x and x square would be without that root, so this would be r square plus L square, and cos theta would be adjacent upon hypo, meaning it would be L upon x. So L upon x as in r square plus L square root. This root we can write as power notation, and we can write this as r square plus L square and r square plus L square raised to half. We can write this expression as this. Now using this property, a raised to m into a raised to n can be written as a raised to m plus n. The same way here its power is 1 and this is half, the 1 plus 2 is 3 by 2. So E equatorial would be somewhat 2k dash q L upon r square plus L square raised to 3 by 2. Here we can further simplify this as k dash q into 2L upon r square plus L square raised to 3 by 2. But we know q into 2L is nothing but dipole moment. Therefore, E equatorial can also be written as k dash p upon r square plus L square raised to 3 by 2. So this is the final expression for electric field at any equatorial point due to an electric dipole. Now here we can have a case when r is very big than L, then r square plus L square is nearly equal to r square. So therefore in 3 we get equatorial as k dash p upon r square raised to 3 by 2. This 2 get cancelled. This becomes k dash p upon r cube. So ultimately we get E equatorial as k dash p upon r cube. So this is electric field at any equatorial point due to an electric dipole which is short. Short as in when r is much greater than L, it automatically means it is a short dipole. So this is the expression. Now if we see E axial electric field at any axial point for short dipole, it is 2k dash p upon r cube, and electric field at any equatorial point due to an electric dipole which is short is given by k dash p by r cube. Thus we can say E axial is 2 times of E equatorial for a short dipole. For a short dipole. Hence, this relation is established.